Hello, folks. This is Spiralink. Today, we're going to be building a phase modulation synth. So, what is phase modulation synthesis? You take a steady tone, the carrier, and modulate its phase using another signal, the modulator, to generate complex, harmonically rich waveforms. Accidentally discovered by John Chowning, phase modulation and frequency modulation are essentially two sides of the same coin. FM can be viewed as the time derivative of PM, and vice versa. In practice, they often sound the same for many musical uses. The DX7 by Yamaha made the sound world famous, marketing it as FM, but the implementation under the hood was actually PM. So, same musical idea, different digital plumbing. So, let's break down the build of our synth. Let's zoom in over here. Bring in a comment. I find it to be quite useful to break down the synth build, or for that matter any build that I'm engaging in, into smaller chunks and then follow through as I'm building it along. So we want some sort of a synthesis engine, of course, which implements our phase modulation. We want voice handling because we want a polyphonic synth. Then we want an amplitude envelope. And we want some modulation envelopes as well to modulate the timbre of our sound. Then we want some LFO modulation sources to get more movement and make our sounds a little more dynamic. We, of course, want MIDI handling functions. This would include taking MIDI note input for pitch, velocity, envelope triggering, so on and so forth. And as mentioned earlier, voice allocation and voice management for our polyphony. Then we also want some sort of a preset management system so we can easily store and recall various synthesis settings. And eventually, we'll also add some effects to the signal chain. Now, for the purpose of this tutorial, I won't actually develop these effects from scratch. We'll just be using effects from the ABL Max library, which should be available to you if you're using the latest version of Max. It comes bundled with that. These are essentially the Ableton code base and all the effects and synthesize modules and everything that comes with that. Very fun, very useful. Highly recommend checking those out. So we're going to zoom out, and I'll put this nicely to the left over here, top left. I think I'm coming down with a bit of a cold. All right, so let's start with our phase mod synth engine. So let's start with that. So we want to build a 4-operator phase modulation synth engine. I'm going with 4-operator because I think that's a nice sort of blend between simplicity and complexity in terms of implementation and sound generation as a whole. So I'll call the sub patch that I've just created Phase Mod Synth Engine. Awesome. And usually, if you have a second window, this new subpatch opens up over there. And before I proceed, I'm going to go ahead and save the main patch. I'll save it in this subfolder, subdirectory called Phase Mod Synth Tutorial. You can call it whatever you want. Just give it a meaningful name. I think that's important. And for the patch, I'm just going to keep it simple and call it the main patch. Super. And then for the sub patches as well, I'm going to save as and name it and keep the name the same. We can just keep calling it Phase Mod Synth Engine. Super. Right. So our synth engine will be deployed inside of a polytilde object. And to get output of polytilde, or rather from polytilde, we want to use the out tilde object. So I'm going to plug that in. I am going to proceed bottom up for now and build from there, because there are certain things in the signal chain that I know I want to be adding, and which is not necessarily part of the overall synth architecture, but just quality of life improvements that I keep implementing in my designs. I'm going to implement and add a hyperbolic tangent object. So that's tan h tilde. And what that does is you use the tan h tilde object to calculate and output a signal that is the hyperbolic tangent function of each sample of the input signal. Or in simpler terms, it imparts a sort of soft clipping, as you can see in these two scopes over here. So you have a sine wave, and then it's essentially being clipped into a square by increasing the amplitude. So basically what this does is it, one, prevents our signal from undergoing harsh digital hard clipping. And also in terms of sound character, if we do overdrive the sound, there is this soft clipping aesthetic that I quite like, which we implement in our signal chain. So I'm going to go ahead and close that patch. And now I'm going to add a times tilde object. And I will explain in a minute what this is going to do. So I'm going to use this as an amplitude level controller using a send and receive pair. I'm going to name the receive object amp underscore level, and I will connect it like that. Now I know when I eventually set up the control parameters for the synth, I'll be using live dials, which output a value between 0 and 127, but I want the control parameter to internally only range between 0 and 1 to control the amplitude of our synth. So I'm going to divide the incoming 0 and 127 data by 127, which will scale our value down to a range between 0 and 1. And I'm going to impart a slewing function using a line object, or a line tilde object, actually, in this case. And I'll add that over here and that over here. So essentially what this little subcircuit is going to do is every time this message box receives an input, it will change the $1 variable into whatever it is receiving. And then this entire message will be sent to line tilde, which will then ramp up from a value of x to a value of y, with x being the current value and y being the next value, at a delta of 33 milliseconds. It just helps in slewing the entire control data and prevents clicks and pops when we, or if we rather, change the amp level parameter very quickly. So now that that is set up, we're going to leave it over there, and we're going to bring in an in object with the argument or attribute 1. So that will be input 1 of our patch, our sub patch. And this is basically going to take input, of course, for MIDI pitch. I'm going to zoom in a little bit. velocity, and of course note on/off. Right. Now I'm going to send the output of in into a swap object, and essentially what this will do is when swap is sent a list, which is going to be the output of the input object, with the first value being the pitch and the second value being the velocity. Swap is going to swap them around, of course, with the pitch coming out from the right inlet and the velocity coming out from the left inlet, which allows us to modify the order of operations, which will become useful and evident later on in this build. And we'll come to that in a second, or well, a little more than a second. So we'll take the pitch output and plug that into a mTOF object, which essentially converts a MIDI pitch value of the note into frequency value, which is going to be recognized by our oscillator. And then we are going to store that value in a float object. We're only going to store that value by sending it into the right inlet of the float object. So what the float object essentially does is if you send in a value in the right inlet, it only stores the value, and then if you send in a bang, it outputs the value. And we are going to send it into a message box called Hertz1, which will essentially prepend the frequency value with the string Hertz. And then we are going to plug that in our gen tilde object, which we are now going to create. Now we are going to build most of our core synthesis engine inside of this gen tilde object. So if we plug those in and just align things quickly. Okay. Yeah, we won't mess about with this too much. I like to keep things aligned. It just helps with readability later on if the patch or when the patch gets complicated. Cool. So we're going to open up our gen tilde object, and in our gen tilde object, we will see we have a couple of defaults. We'll remove all of that, and we'll place our output right at the bottom. And inside of this gen tilde object, we are essentially going to be building our entire core phase modulation synthesis setup. And the way we are going to set up how our oscillator or our synthesizer treats frequency is we're going to have a base input frequency, and then we are going to have different ratios of that specific frequency feeding into our carrier oscillators and as well as our modulator oscillators, which essentially makes it possible for our synthesis or our synthesis engine to essentially retain a sort of harmonic relationship within all the oscillators. There are other ways to implement this as well. We can choose to not have this sort of a relationship, but I want to do this for this build because it allows us to have a nice balance between the more chaotic, clangorous sort of FM sounds, as well as the more nuanced, almost floaty kind of FM sounds as well. Right. I am again going to build this a little bit from the ground up, essentially, or the bottom up rather. So first I'm going to implement a DC blocking filter, which, if you might have guessed, filters out any DC offsets in our signal because of our synthesis parameters. And then we'll ensure that that is fed by a hyperbolic tangent object as well, which kind of serves a similar purpose as the previous one. And we are also going to add a amp mod circuit over here with this multiply object. Let's bring that all the way out over here. And basically what we're going to do is we're going to create an inlet object, give it the value 3, or well, give it the attribute 3. argument 3 actually, and name it amp envelope. And basically what we are going to do is we are going to send in our amplitude envelope into this, or into our gentle object through this inlet. Now we can move on to the rest of our control parameters. We know we are going to have a parameter which is going to be the bass frequency. I'm going to call it hertz and give it a default value of 200. And then we're going to have another parameter called carrier ratio 1. Give it a default value of 1, and we can just copy that over and call that carrier ratio 2 with a default value of 2. Then we'll have another parameter called modulator ratio 1 with a default value of 2. We will have another input with the argument 1 and call that input index 1 mod. So this will be the first signal input of our gentilda object, and we are going to be sending in the modulation sources that we design later on into this object. And we are also going to have another parameter called index1, which in FM or PM synthesis world, index essentially means the depth of the modulation parameter, or in this instance, depth of the modulation itself. We are then going to copy this thing over and maybe like move these a little bit to the left just to keep things tidy. And we're going to call this ratio 2 with a default value of 4, index 2, and input 2 as well, and then same for this with index 2. And we also ensure that the minimum index value is always 0 by setting that up with this with the min attribute. All right, now let's design our oscillator circuit. So first, what we're going to do is we're going to multiply our bass frequency value by the ratio to set the final oscillator frequency. And we are going to use that to drive a phasor object, or set the frequency of that phasor object, which is essentially a ramp accumulator ranging from 0.0 to 1.0. And then we're going to multiply the output of that by a times object and 2 pi, with a times object and by 2 pi. Essentially what this does is it converts our ramp into degrees in radians. So it sort of becomes an angular integrator, and we are going to send that into, well, it becomes an angular modulator, and then we send that into the sine object, which essentially creates our sinusoid oscillator. And now if we copy this entire signal chain over, we can patch this up, and this is our second carrier oscillator. And we can carry that over, or copy that over, I guess, one more time for our modulator, for our first modulator oscillator as well, because we're going to be using a sinusoid oscillator for all of these to keep things simple, and also show how you can have these simple building blocks and still generate really complex soundscapes and sound design using just these sinusoid oscillators. And we'll set up our modulation envelope, or well, we'll adjust the modulation depth of our envelope by multiplying it with the index value, and we'll value, send the output of that value of that calculation into another times object, which essentially, and what this is going to do is uh, this is essentially going to handle the amount of, or the depth of modulation of our modulation oscillator affecting our carrier oscillators. So if we plug the output of that into the sine objects, we'll essentially vary the phase of our sine objects based on the frequency of the modulation oscillators. I also like to add some slide objects to control parameters. What slide does is it imparts a slewing function as well. Yeah, and it basically just, again, I think it's good patching practice, and it prevents any sort of pops and crackles happening when you modulate a parameter really quickly at audio rates, or even at event rates. And we're going to then send the output of that into an add object. And once we've done that, what we can do is we can copy this entire subcircuit and just bring that over here and patch this up like this. And that is our second modulator oscillator. And we add those two together, and we will send the output of that into our sine objects. And we also want to blend these two carrier oscillators together to create more complex sounds, and we'll use the mix object to do so. And we'll add another param called blend to blend between the two oscillators, and we'll give it a default value of 0.5 with a min value of 0 and a max of 1. And we'll also add these slide objects over here. That's just useful. And this basically completes our core synthesis engine inside of Gen. I'll just quickly go over the patch. Yeah, and yeah, this basically completes our synthesis engine, and we can close the Gen tilde object now and move on to developing the rest of the ADSR envelopes and modulation sources. So now we're going to set up our amplitude envelopes, the modulation envelopes, and also the control parameters for our synth. And we're going to do that, but first we're going to just enlarge in this. Great, let's start with all our synth parameters. We'll create another receive object called pm underscore synth underscore params. And I know our synth has 7 parameters that I want to control. So we're going to create an unjoin object, and let's just keep some space for us. And let's create the message boxes that we'll use to prepend the name of the control parameter of our, which is present inside gen tilde as we've named them, and add our control value to them, similar to what we've done with hertz and $1. So let's just go ahead and do that. We have carrier ratio $1. Then we have carrier ratio 2. Then we're going to have the blend up. Then we'll have blend setup. Then we will have our modulator ratio 1. And then we'll have index 1. And then we can just copy these two over after bringing them down a little bit and rename them to mod ratio 2, or well, modulator ratio 2 and index 2. And if you want to be fancy, we can just select them and then distribute them vertically, just to keep things neat. And we can plug all of these directly into our gen tilde object. We can select them and route them like that, just to keep clear view of all the cables in the patch. This is really helpful when the patch starts getting bigger and more complex, and it's just a lot easier to read your patch when everything is nicely organized. Good bit of patching practice. Great. So once that's done, I'm just going to make a little bit more space for the rest of the design and the circuits. Right. So once this is done, I'm going to go ahead and start building the ADSR parameter setup. We'll create a receive object called ADSR amp params. Set that up over there. And I know we have 5 parameters of our ADSR. So we have the attack, decay, sustain, and release parameters, which correspond to the attack, decay, and sustain release parameters of the ADSR tilde object, which we'll use to create our envelope. But I also like to add another parameter, which shall be called depth, which controls the depth of the amplitude modulation affecting our circuit and our synth design. So let's bring in an ADSR tilde object, and we can go ahead and patch these up. Maybe just do that so we have clear view of our patching. And once that is done, we're going to add our depth parameter after this in the signal chain using the circuit that we've built before as well. And we'll plug that in, and we will now have our circuit ready. I'm also going to add a sig tilde in between. I think this is also good patching practice because we're changing an event data into signal data with the sig tilde object, which basically what it does is it converts regular numbers into audio signal, and we use that to control our modulation depth instead of direct numerical computation of modulation depth using straight numbers, which can sometimes result in clicks and pops, and this just prevents that from happening. Although we will create an additional sort of slewing function which will help smoothen out our input control parameters, but that comes later in the build. And then we can just plug that in over here, and this is essentially our circuit, our amplitude envelope. And there are a couple of more things that I would like to add just to enable voice handling and voice allocation using the this poly object, which is used in conjunction on inside of a poly tilde object. And what this does is this poly object, when inside of a poly tilde object, it controls voice allocation and muting, which is going to be very handy for our polyphonic patch. We're also going to add an edge tilde object, and what that does is it detects logical signal transitions at its input, and then based on whether that signal transition is a 0 to non-zero transition, it sends out a bang on through its left output, and if it's a non-zero to zero transition, that comes out through its right output. And what we are then going to do is we are going to use that bang to bang out the stored pitch information. So effectively what this does is every time a new envelope is triggered, we bang out the stored pitch value correlating to that triggered envelope. So our pitch and envelopes always trigger in cohesion. Now, we also want to send in a signal or a float to trigger our ADSR tilde object, but the velocity values that we get from MIDI input is going to be between 0 and 127. So we're going to just copy this object over here to convert our input signal into and basically map that to a range between 0 and 1. I'm just going to do a quick bit of housekeeping to keep things in order and just neat and help us. I'm going to bring these all the way down. Same for our edge tilde object. And maybe do that. Yeah. And we can do that. And yeah, that's great. Now if we select all of these and if we distribute them vertically, super. Nice and clean. Great. And that is essentially our ADSR envelope all set up. And what we can now do is we can just copy this over twice to create our modulation envelopes. And I'll show you how we can do that. We don't need the edge tilde and this poly tilde object, so we can delete those. We'll bring the sig tildes all the way down so that we have clear patch lines, as clear as possible, really. Maybe bring all of these down a little bit. That's great. And we are going to plug the velocity in over here and then plug these into our modulation inputs and route them so. And also change our ADSR receive names to mod1 and mod 2. And that basically is our envelopes all set up. I'm just going to quickly align these, slide them to the bottom. Amazing. And I think now we can move on to our LFO modulation source. And for that, we are going to build a subpatch called LFO underscore mod underscore 1. And inside of the subpatch, we are first going to create a receive object and call it LFO underscore mod 1 underscore param. Then we are going to have an unjoin object with an argument of 2 because it'll be receiving 2 variables as a list, which we will use to feed 2 sig tilde objects to convert these numbers into signals. And then the first one will control the frequency, or rather set the frequency of a cycle tilde object. And the second one is going to control the modulation depth. Again, I'm using a cycle tilde object over here for simplicity. You can, of course, use any other waveform that you would like as a modulation source. In Max, of course, there's tri tilde for a triangle oscillator. You also have a rect tilde for a square wave with pulse width modulation. So, and you could also use a noise source. That's entirely up to you. And then we're going to have an outlet object to send the low frequency oscillator output out from our patch and out from the sub patch and into the main patch. And if we just duplicate that, rename that to LFO mod 2 and that to LFO mod 1, rather mod 2 param, then we have both of our LFO modulation circuits ready. And we'll just plug these in as well. Maybe get some height on these so not everything gets muddled up together. Or we could just leave it at that. And with that, we have our synth engine all built up. We can now move on with the rest of our synth design, which in this instance is first going to be voice handling, and then I'm going to move to handling the MIDI. Right, so first we're going to set up the voice handling as well as the MIDI handling, and it's a pretty straightforward patch. So first things first, we are going to open up the sub patch and we're going to save as and save that. And then we're going to open up a poly tilde object, name it phase, and then give it the patcher name of our synthesis engine, which is Phase Mod Synth engine, or whatever engine name that you've chosen for your synth design. And we're going to instantiate it with 8 instances. You can choose 16, 4, 2, whatever you feel like. Then we're going to give it an voice. Then we're going to enable voice stealing and also change the target attribute to 0, which ensures that all the data input to our polytilde is basically sent to all the instances. And we can connect the output into our gain tilde object. So just to do a quick recap, we have our 4 operator phase modulation synth engine. And then we have the polyphonic version of this. And now we're going to go ahead and set up the MIDI handling aspect of this patch. So let's create a sub patch, call it MIDI handling or any other name that you would like. And bring that window over here. We are going to create 2 pairs of inlets and outlets and connect them. We'll copy that over and we have these 2 pairs. And then the first object that we want over here is a MIDI in object, which outputs raw MIDI data that is received from any connected MIDI controller. We're going to send the output of that into a MIDI parse object, which interprets the raw MIDI data for us. And then we are going to take the first outlet of MIDI parse, which gives us note on and note off and a list, which is the pitch and velocity. And we are going to prepend the message MIDI note before that list using the prepend object. I'm going to zoom in quickly and see I've got the spellings right. And now that we have that, let's just plug that in over here. And then in the second inlet and outlet pair, we're gonna add a MIDI info object, and we're gonna create a load mess object and give it a message of 0, which essentially means that whenever this patch is loaded or instantiated, the load mess object sends out a value of 0, which forces the MIDI info object to populate a U menu that we are going to create with the names of all the connected MIDI devices that we have. And we can close this patch. Let's connect the output of that into our synth engine. And let's create a U menu object as discussed earlier. We'll add that over here, connect the second outlet into the first inlet. And then we are going to create a bang object into the second inlet and then patch this like this. And if we hit bang, we have a list of all our connected MIDI devices. So I'm going to select the one that I want to use, and we still will not have any sound yet because we've not set up the input values of all our synth parameters and LFOs and amplitude modulations and whatnot. So we are going to go and set those up now. So now we're going to start setting up all our control parameters. So essentially this is going to be the control layer of our synth, which will include a control for the amp level, then for all our ADSRs, including amplitude, mod 1, mod 2. We are also going to have an LFO controls, and then we'll have the synth parameters itself. So we're going to start by, well, we'll start simple, and we'll start by setting up our amp. So we know we have an receive pair called amp level. So we're going to create a send called amp level. quick recap, we have this receive called amp level. And then we're going to create a live.dial object. Now I already have a custom version of this object that I've used before, so I'm just going to copy that over from another patch. And if you hold, and this is a very neat function in Mac, so if you hold Command, Option, and V, it does a special paste function where it pastes the copied object and imparts all of its custom settings into a new object. I can't recollect what the parallel version for this is for Windows, but I believe it would be something like Control Alt V. But yeah, you can ask me in the comments and I'll share the info. And yeah, let's go ahead and call this amplitude. We will change both the long name and the short name of this object. And great, we have that going. And now if we check if this value is coming through, yeah, this value is coming through. Perfect. So we're going to move along and we are going to set up the ADSR envelope, or well, the ADSR envelope parameters. Now we know our envelope has five parameters. So I'm going to create 5 dials. There you go, 4 and 5. And then I'm just going to go ahead and name them quickly as attack, decay, sustain, release, and depth. Right, that's all set up correctly. And we're going to zoom out. And we know our receive object is called ADSR underscore amp underscore params. And we could just double check that. It is ADSR underscore amp underscore params. Great. Now, obviously, we want to pack all of these values together and well, we're going to combine all of these values together and we'll use the join object with an argument of 5, specifying the number of inlets, and a attribute. We're going to set the trigger attributes to -1. What this basically does is, without this particular -1 value, the join object, or rather, let's put it this way, with the -1 value, all the inlets of join are hot, which is also signified by this red or sort of orangish color if you hover over the inlet. Now, if I create another join object with the same number of parameters and not give it the triggers value, and if you check that, you'll see that only the first inlet is hot and all the other inlets are cold inlets. And what this basically means in terms of Macs is whenever an object has a hot and a cold inlet, the cold inlet sets the value of the object or stores the value of the object, and the hot inlet stores and then also outputs all the values. Or to put it in a different way, the hot inlet always triggers an output, whereas the cold inlets don't always trigger an output when a value or a message is sent to those inlets. Now, instead of just sending this in, I'm going to impart a scaling function to the output of these dials. So these dials range from 0 to 127, and our ADSR tilde object expects the attack, decay, and release parameters to be values in milliseconds, and for the sustain parameter to be a value between 0 and 1, and which is the same for our depth mod circuit as well. So there are many different ways to achieve that. The most straightforward way to do that is to create a scale object and give it a value of give it the arguments of 0, 127, which are the input values, and the desired output values, which for me is going to be 1 and 3000. So if we plug this in over here and check the output, right? And like I mentioned, there's many different ways of doing it. Another one would be, and I'm just gonna show the many strengths of a language like Max. There are many different ways of doing things. It just boils down to preference sometimes, and sometimes patching speed. We have that, and then we have another scale object, which is going to range from 0 to 3000 and 1 to 3000. And then we can have another methodology over here, which is going to be that, and then that. They all have the same value. So like I was saying, there's multiple ways of doing this. I'm just going to use the scale object to do our conversion because it just saves time. Well, it usually saves time. I did take up quite a bit of time to explain how things can be done. And then I'm also going to add our slewing function that we've used before with along with a line object, not a line tilde object this time, a line object. And we can just set it up this way. And we can call this entire chain smoothing functions or smoothing and scaling. I'll just call them scaling functions for now. And copy these over. Actually, I'm not going to do that just yet. I'm going to keep this as it is, and I'm going to copy this entire thing over, and I'm going to call that scaling functions. I'm going to open the subpatch, and in the subpatch, what I am going to do is first distribute these a little bit. This should work. Smashing. Then bring that down and do that as well. And then copy that over, and that, and that. then we can just plug that in. We don't really need our scaling function over here. Rather, we can simplify the scaling function by doing this bit of math, this we've done before. And we're going to patch that up like that. And we can just delete that, bring that over here. And patch that up. Just quickly investigate the patch and to ensure we've not made any errors. I think we're mostly good. Yeah, so we're taking an input value between 0 and 127 and scaling that to an output value between 1 and 3000 for these. And then this is going to be a value between 0 and 1. Then again, 1 and 3000 and 0 and 1. We can close that. And if we just move these around, and we should have, yeah, so this works as it should. Super. And then we can just copy these over twice, because essentially these functions are going to be the same, and call this mod1 params and mod2 params. And we'll double check the names. Mod1 params and mod2 params. Super. Great. Quick save. And now we're going to move on to setting up our LFO modulation controls. So I'm just going to quickly tidy. Oh, well, I can tidy these up later. Yeah, so let's just copy these two dials over here and rename the first dial to freak for frequency and change the type to float, the range to 0.01 and 20, because this is going to be the frequency value of our LFO, and change the unit style to float as well. And then what we are going to do is we are going to join these two values together and give it triggers of -1. And we're going to send that to a send object called LFO underscore mod1 underscore params. And we're going to ensure that is the right name. LFO, well, we call it param. We'll just add the S here. Do the same for that, because we have two parameters, so params makes more sense, I think. Great. And we can connect these two, of course, and then we're just going to do a bit of slewing using our slewing function, which is creating this message object, give it a value of 33. And if you ask me why 33, I just think this works quite nicely. I mean, you can try out other values as well, depending on how much slew you want to impart into with your slewing function, rather. And this is mostly going to be the same with one crucial difference. We are going to change the depth range from an input range of 0 and 127 to 0 and 1 with this bit of math. And if we combine or encapsulate all of this into a new subpatch, we can call that LFO1. And then we can just duplicate that over and call that LFO2. And that, I think that should be fine. We'll quickly test all of these out by giving it these pretty arbitrary values just to ensure we are receiving all of these parameters. And let's just quickly test this. Yeah, awesome. Great. Same for that. Super. Let's just quickly test if our LFOs are working. We'll use a live.scope object. Yeah, that seems to be working. We're going to save as again. And what this does is every time we save as our monophonic patch, the instantiated version of the polytilde patch reflects all the changes and updates itself. Otherwise, the changes aren't updated within the polytilde patch itself. Right, so we have all of these set up, and now I think we can move on to our synth parameters itself, the control parameters for our synthesis engine. So we create a send, and we call it PM underscore synth underscore params. And then we copy that over, and I know we have 7 parameters, so let's just copy this over 7 times. That is 6 of them, and then 7th. And I'm just gonna copy over one of our slewing functions from before. Yeah, let's just copy this over. And let's connect it like that. And we are going to, of course, use the join object with these attributes and arguments and connect them like that. And we can create this sub patch called slewing function. Right. And then we can just connect these like that. And we can encapsulate this and call this PM underscore synth underscore params. And in our patch, sub patch, let's just drag that all the way to the left, right there. Yeah, let's do that. Let's select all of these and then we'll distribute them horizontally. That's fine. Let's create some space for us over here. And let's just plug these in here. Right. So now we can rename these and also edit these dials to better reflect the control values that we want. So we will call the first one C1 ratio for carrier 1 ratio. We want that to be a float ranging between 1 to 20, and we are going to change the unit style to float as well. We'll copy that over to these dials. The second one, the fourth one, and the sixth one. And we're going to rename these C2 ratio, C2 ratio, M1 ratio, M1 ratio, and of course M2 ratio, M2 ratio, and M2 ratio. Great. Yeah, that's all set up. And then for these, we will call these. These are also going to be floating values. Actually, just the range is going to be different. So the range between 0 and 1. And we'll call this blend. We'll copy these over and paste these into the 6th and 7th object and rename them index 1, index 1, and index 2. Then a quick save of the patch, check what error we have. Okay, we don't care about that. And now we should have complete control of our patch. I like to visualize the output because it looks pretty and I'm also a very visual person. So we'll use a live.scope object, change the range to -2 and 2, and then plug that in. Keystep Pro, and if our patching has been correct, we should get an output. I'm gonna turn down our amplitude a little bit and slowly turn that up. Great. Okay. Our amp envelope seems to be working fine. So let's just mess about with these for now. We can do proper sound designing later. That seems to be working as it should. Great. So we have our synthesis engine more or less sorted out. There are a couple of things I want to check. Yeah, just to ensure we have it's working as it should. so a quick troubleshooting is required because our LFOs seem to not be working as they should. We're just going to quickly check what's happening over there. We know these are working. So this is our LFO mod 1 params. Yeah, that seems to be working as it should. Right, that's fine, and that's fine as well. Param 2, index 1, 1. Yeah, that's also fine. Okay, let's see what's going on. Okay, our ADSRs are working as they should. But our LFOs aren't. So let's just investigate what's going on over there. We have LFO coming out from there, but that's not affecting our poly tilde. Yes, so we see that for some reason that's not going through. Oftentimes if we just, well, let's first create a preset object. We're going to do that because we made a lot of changes in our synth design. I mean, this is probably not the best bit of sound design, but let's create a preset so that we can jump back into this shortly. What we're going to do is sometimes you need to save as your main sort of bass patcher. And even though you do a save as function, it doesn't reflect in your poly tilde object. And we'll see if that is the case. As you can see, that was the case. It's a strange bit of a bug, but it is what it is, and we have what we need. I think that's a much better, well, that's definitely better than our first preset, but just to show how the preset works, you have the first preset, and then if you shift click onto an empty slot, you can store a new one. Actually, that's not bad. All right, so the last thing that we have to do is set up our FX chain. So let's go ahead and do that. And as mentioned earlier, we want to use the ABL devices and ABL max set of objects rather. And I want to use the phaser because I like that phaser quite a bit. And I also want to use the delay because that's a pretty straightforward delay to set up and use. No frills, just works as a delay should. And let's create a bunch of Atter UI objects. Right, and I think we are good with 3 for the phaser because I know what controls I want to control. And we want to create 4 of these for our delay. And we'll just plug these in. And I want to control the dry wet function, the warmth function, and I also want to control the number of notches, maybe, or maybe just the LFO amount. Yeah. Let's do that. Great. And then for this, we want the dry wet, of course. We want to have ping pong mode enabled. We also want to have the delay times. And I think that's it. I don't really need this one. Great. And now if we try that out, that's quite nice. Great. So to round things off, we're going to set this up so we can open our patch in presentation mode. And I'm going to show you how to do that. I'm going to add a couple more things in here just to give it a bit of aesthetic niceness. So with our scope, we're going to make a couple of changes. And now, because we have a stereo patch, we can do something like this. Reduce the opacity a little bit, like maybe 71% is fine. And let's do that. And well, actually, before that, let's connect that there and that there. And now if we test, and now if we play, quite nice. Right. So all the controls that we want to have in presentation mode, we're going to right click on them. Well, first we're going to select them, which is going to be all of these. And yeah, we're going to right click on them and we're going to say add to presentation. Then I also want to make a couple of changes to this preset object. Make the active color green because we're really leaning into this green aesthetic. And then the stored color, we can make that like a darker green perhaps. And then with our empty color, we can choose maybe white. Oh, that's really white. Maybe like that. Or we could just go with more green. Let's choose that and maybe that. Oh, that's the text color. I didn't want to change that. I wanted to change the empty color. Let's go with green. that's really green. And let's just reduce the opacity a little bit. I think that should be fine. Maybe that's a bit much. I mean, that's fine for now. So what we're going to do is we're now going to go into presentation mode. We can click here, or on our keyboard, we can use Command Option E on a Mac. Oh, and there's one more object I forgot to add, which is the panel object, right? So let's make our edits to that as well. More of the green, and that, and that. And let's do the interior color to be quite black. Great. And we'll add that to presentation mode as well. And now we're going to jump into presentation mode. And let's arrange our controls. Yeah. Like that, and then that. We can add that over there. We can add those over here. I mean, you can arrange them any way you see fit in terms of your aesthetic choice, as well as, well, not just aesthetic choice, but also a layout preference that you might have. I prefer this, but yeah, this is entirely up to you. This is a personal choice. And I'll add that over there. Let's add these over here and do that. And then I'm going to select all of these and align them to the left, and keep doing that for all of these. Cool. And we have these all nicely aligned. Yeah, this looks good to me. And we can set this up like that. And if we just send this to the back, and maybe a couple more edits, do that, and that maybe. Yeah, I think we have our synth design nice and sorted. Put that in the center of the screen, roughly. And something else that I like to do is select the patcher inspector and change the locked patcher background color to black. And there you go. This is the final synth as promised. I like that preset. I'm going to save that. And we have 3 presets. Let's try and make something a little more harsh. I haven't really added these Atter UI objects to our presentation window, but you can do that as well. Yeah, that's some nice grit over there. Let's ditch the mix on the delay and see if we can get something really nice. And I will save that as well. And yeah, that's pretty much it for our tutorial. I hope you had fun and you enjoyed going on this little journey with me. And yeah, that's pretty much it for the session. If you like this tutorial, then please hit like and subscribe to my channel. I will be creating more Max MSP tutorial content going forward, and also posting other stuff relating to my sound design and composition work, as well as my practice with neural audio synthesis and procedural audio and all those good stuff. Also, if there's stuff you'd like me to cover specifically, then please leave a comment, and also leave a comment if you've got any questions, and I will do my best to respond. And yeah, that's pretty much it. That's a wrap. See you next time. And thank you for being here.